Question 3. Naomi produces oak tabletops, each of area 4.8 meters squared. Defects in the oak tabletops occur randomly at a rate of 0.25 per meter squared. A. Find the probability that a randomly chosen tabletop will contain at most 2 defects. Let's consider this and think about what distribution is it. The question talks about the rate. Anything that has a rate is a Poisson distribution. The number of occurrences in a volume, the number of occurrences in an area, the number of occurrences in a distance. Anything like that is Poisson. The area of the tabletop is 4.8 meters squared, and the rate is 0.25 for every meter squared. So this is a Poisson distribution, and the mean number is 4.8 times 0.25, which is 1.2. If x is the number of defects, then x is the random variable, which is Poisson, with a mean 1.2. The question asks us to find the probability of at most 2 defects. So we require the probability x is less than or equal to 2. We shall find this out using our Classwiz calculator. So press the menu button, and then we want statistics. So now press 7. This shows us some statistical distributions, but we want the Poisson. So scroll down. We then get the display shown, and there are 2 Poissons, the probability distribution and the cumulative distribution. We want to use the cumulative distribution, which is 3. This now shows us the screen, and we have a choice of list or variable. We want to variable. X is the cumulative occurrences. So we want x to be less than or equal to 2, so we will put in 2 at the x value. Lavender is the mean number of occurrences for this Poisson distribution, so we want to feed in lavender is 1.2. Remember to press equals after you enter both of these entries, and if you press equals again, we get the answer for the probability that x is less than or equal to 2, which is 0.8795 to 4 decimal places. The probability that x is less than or equal to 2 is 0.8795. Now let's look at part B. Find the probability that in a random sample of 7 of these tabletops, exactly 4 will contain at most 2 defects each. Although part A was about the Poisson distribution, part B is about success or failure. This is the binomial distribution. We will either get exactly 4 of such tables, or we will not, success or failure. So press menu 7 again on your Classwiz to get it into stats mode. We see the display in binomial is there, and this is the probability distribution, which is the one we want. We don't want the binomial cumulative distribution because we want to find out the probability of exactly 4. So we want to calculate using the probability distribution. This leads us onto this screen where we press 2 for variable again. Enter X as 4 because 4 was the number of tables we wanted. Enter N as 7 because there were 7 tables. And P as 0.8795 because that was our answer from part A of getting at least 2 or less tables with this probability. Press equals and we get the probability that y equals 4 is equal to 0.0036. And this is our answer. We had been considering the random variable y, where y was the number of 4.8 square meter tabletops containing at most 2 defects. We knew that n was 7 because we're considering 7 tables, and p was equal to 0.8795, which was the probability that a table contained at most 2 errors. And note that we wanted the probability that y was 4 because we wanted exactly 4 of these tables to have at least 2 or less errors. The question was about Poisson and Binomial. Let's just look a little bit more at the binomial first using Geogebra. Here we have the binomial distribution with n is 10 and p is 0.5. The mean of that binomial distribution is np, which is 10 times 0.5, which is 5. Notice the binomial distribution is a symmetrical distribution centered at 5. If we use the slider and change the probability from 0.5 to 0.8, the distribution then changes. The mean of this distribution is NP, which is now 10 times 0.8, which is 8. So the mean is at 8, but this distribution is negatively skew. The graph of binomial 10, 0.8 is negatively skew. Notice that most of the values to the left are in a long tail and have very low probability, but it is possible to have a probability that x is equal to 1 or 2 or 3 or even x equals 0. But it is more likely, the mean is that x is 8, so this graph is centered and there are more possibilities of values close to 8, but we have a negatively skew graph. And if we change the probability down to 0.15, say, we get a new graph, and this graph is positively skew. The mean is NP, which is 10 times 0.15, which is 1.5, so that we can see that the most likely outcomes, the mode in this case is 1, and the probability of 2 is quite high as well. But the graph is positively skew as there is a long tail to the right. But remember, some of these probabilities are possible, but are very, very low probabilities, getting as low as possible as you go towards 10. If we go back to the binomial distribution 10, 0.5, the number of occurrences can be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These are all possible, and we have the nice symmetrical distribution. If we change n to be 9, the possible values go from 0 up to 9, and we get 2 mode values for 4 and 5, so it's just like finding the median of numbers 0 to 9. Again, if we just move down to 8, it becomes symmetrical again with only 1 mode, and if we move down to 7, there are 2 modes. Let's now look at the Poisson distribution. So we're considering a Poisson distribution here with mean lambda equal 5. Notice this distribution is not symmetrical. The most likely value you can get is 5, and the probability of 5 is one of the highest probabilities, but getting 4 is equally as high a probability. The values that you can get with the Poisson are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, but these are all possible. 14, 15, 16, all these values are possible. The binomial had an end to it, but the Poisson, all possibilities would be possible, but very, very unlikely. When we consider a Poisson distribution with mean lambda equal 8.5, and if we look at the graph looks as if it is fairly symmetrical, but there are less possible values to the left of the mode, and there are more possible values, remembering you can get any value, so there is a long tail to the right of this distribution. So this distribution is positively skewed. The graph looks symmetrical, but if we look at the probability that x equals 5, it is not the same as the probability that x is equal to 11, even though by eye it does look fairly similar. The higher we make the value of lambda, the curve becomes more symmetrical. So for large values of lambda, the curve is symmetrical, and it becomes closer and closer to a normal distribution.